Welcome students. Let's now discuss this question, which is again graph based question. There are a lot of graph based questions in competitive exams, and you have graph concept has to be very good in understanding this. So now we are talking here about relative motion as well as graph. So there is a cliff somewhere here. If I will draw it like this, and from the top of the cliff, the height of the cliff is 240 meter, and from here two stones are thrown up. This is with 10 meter per second, this is 40 meter per second. Right, 1 and 2. The displacement of 1 is denoted by y1, and displacement of second is denoted by y2, right? And the graph is y2 minus y1 versus time. So we have to analyze a graph y2 minus y1 versus time. Y2 minus y1, that's a relative motion of 2 with respect to 1. So let's first see what happens. Since this has got a speed of 40 meter per second and this has got a speed of 10 meter per second, the first one is going to just rise to some height and then fall down. This is going to rise a little further and come to ground after some time, right? So for some time both of them will be in the air. The gravitational force will act on it. So the displacement, as long as they are in the air, their displacement is going to be given by y1 is equal to 10t minus 1 by 2 into 10 t square. G is given to be 10. So this is going to be equal to 10t minus 5t square. Similarly, y2 is going to be equal to, for second equation, 40t minus 5t square. So as long as they are in air, these equations are valid. Y2 minus y1 is going to be equal to 10t minus 40t minus 10t, that's 30t. So this simple straight line. Okay, y2 minus y1 versus t is going to be a straight line. So the graph is going to be like this. As t increases, this is going to increase. Now, it's what happens when this will hit the ground. First stone is going to hit the ground. So what we are going to do is we have to find out the time in which this stone will hit the ground, because this graph will end when the stone hits the ground. So how do we do this? This is going to go up and come down, and then displacement of this is going to be minus 240. So in this equation, if I put y1 is equal to 240 meter, because this downward displacement is minus 240. So y1 is going to be minus 240 is equal to 10t, let's say 1, minus 5t square, t1 square, right? So that is the time at which it is going to hit the ground. So this is a quadratic equation again. So let's solve this, and I can divide it by 5. So it's going to be t1 square minus 2t1 and minus dividing by 5, 48 equal to 0, right? So that's going to give me t1 minus 8, t1 minus 6, sorry, plus 6 equal to 0. So I'm going to get t1 is equal to 8 seconds. So after 8 seconds, this particle is going to hit the ground. Right? So it's going to be 8 seconds. This graph is going to end at 8 seconds. And what will be relative displacement? I'll just 8 seconds. If I put here 8 into 30, 240. So this is going to be 240 that means relative displacement being 240, when the first stone is here, the second stone is going to be here and traveling in the downward direction, right? Now from this point onwards, I cannot use this relation. I have to use now, because one stone is at rest, the another stone is going to slowly come down, not rapidly come down, okay? And the motion of this distance, whatever will be there, the distance will be the parabolic variation, because it is only the second stone which will be moving. So the second stone, now there are two options. One is going to be, I am going to discuss both of them. One is like this and another is like this. So now let us logically argue this. I can mathematically prove it to you, but then it is always good to use logical argument, because in competitive exam we don't have much of a time. If let me draw one first. It's a very common sense that as this second stone is coming closer to the ground, its speed will increase. So it will cover more and more distance in a given time interval. So now I'll draw both of the graphs so that you can understand. One I'll draw like this and another I'll draw like this. Okay. Roughly, I think it's the same level. Yeah, anyway, you will understand it. So now, if I take a small time interval here, let's say here, let's say this time interval, its displacement changes by this much. And if I take a same time interval here, its displacement changes by a small amount. Right? So as I told you, as this second stone, after going top and coming down, it is rapidly accelerating, rapidly coming to the ground. So its velocity will go on increasing. It will cover more and more distance. Therefore, in the given time interval, it will cover more distance. So here it is less distance, here it is more distance. So the right option is going to be this. Straight till here and then rapidly dropping down. Got that?